Hello everyone, welcome back to the channel and you're watching Komal Taya. So guys, I hope you all are doing well and preparing well for your exam. In the last video, I talked about one question inspired from previous year question only. Basically, previous year question was June question, which was related to particle in 1D box, and you need to find out the trial wave energy was greater than or less than, like that. And then I took a similar example, but a lot more complicated for SHO. So for people who are seeing me for the first time, you can go back and see those lectures. So they are the immediately last lectures, so you can just go there. But in today's video, I'm going to take one question which came in December 2014. So let's just see what that question looks like and how that question is different from other question. Everyone just pay attention over screen so you can see over here. So this second question we discussed already in the last video, and this 12th question I'm going to take in this video. So according to it, for some one electron system with L is equal to 0 and M is equal to 0, okay, L value is given and M value is given, the function N0 E minus sigma and N1 2 minus sigma e raised to power minus sigma by 2 refers respectively to the ground state and first excited state. Okay, electron system is there, right, and this system belongs to ground state. Its energy is given that it is E naught, and this function, suppose this is psi naught, and the ground state energy is given, and this is psi 1, and its energy is denoted by E1, and this is first excited state, right? This is ground state and this is first excited state. Clear? So these all things have been given. So if a variation function, so now some random variation function, that means a trial wave function or approximate wave function has been taken. So I'll just write psi trial has been given like this: n3 3 minus sigma e raised to power minus sigma by 2. Its yield and average energy, this E, simple E. So the energy, whatever energy it will yield, it will be denoted by this E, and it will satisfy these conditions. You can see A, either E is equal to 0 or E is between 0 or E naught. What is E naught? Ground state energy. Either E is greater than E1, which is first excited state energy, or E is between this ground state energy or first excited state energy. So clearly this question looks a little bit scary because it involves sigma and you don't have any idea how to solve it. So first of all, so you can just take, and this question came in December 2014, I have written over here. So basically you have to take idea from this thing only, that okay, different kind of options are given. So that means you need to find that this energy, this is trial wave energy. So you need to find that whether it is greater than or equal to greater than exact energy. So you need to find, but like which energy it is greater to, or which, like there are two energies, right, E naught or E1 or like that. So you need to find out first which state they are talking about, because I told you the first motto, if you are given like this, it like options are given like this, greater or less than, so your first motto should be like whether this E trial and E exact are belonging to same state or not. So you need to find E trial, this E trial wave energy, which is denoted by E, should be of same state, like either it can be of ground state also or first excited state also. So you should know that this trial wave function belongs to which state. Either it will belong to ground state or it will belong to first excited state. So how will we solve that? How will we approach for that question? How will we go for that? So I have solution listed down with me. So let's just go there and let's just see in that solution. So okay, this is the answer 12th, if you can see clearly. L0 it is given, yeah, M0 it is given again, okay. So this function is given, this is psi naught, Clear? And this function is given, this is psi1, psi naught is n naught e raised to power minus sigma, and it is, energy is denoted by E naught. So it is psi1 and energy is denoted by E1. Clear? And this is trial wave function, which is n3 3 minus sigma e raised to power minus sigma by 2. So first my motto is, I need to find out this wave function belongs to this state or this state. So for that, what I have to do? I have to find n value, because if n is same, obviously states are same. If n is same, then states are same. Right? So what will I do now? So for finding out which n it belongs to, which state it belongs to, I told you one thing, that put everything equal to 0. Like, you need to find out how many nodes are there. So if you get to know how many nodes are there, you can find out what is the value of n. Clear? You can find out what is the value of n. Clear? So let's see what is the like how to calculate node. So I told you, for calculating node, what you have to do, you have to put whole wave function equal to 0, right? So if you'll put, you can see over here, no node is there in psi naught. In psi naught, no node is there, because you can see n naught equal to 0. These are just boundary condition. E minus sigma is equal to 0. That means sigma is equal to infinity. And these are boundary conditions only, right? So what I have to do now? I have to, so this function does not have any node. So what I'll do, let me just first rub it, so things will be more clear to you. Yeah, so so now the first function, like, which is ground state function, has 0 node. If you have any doubt, guys, please leave it in the comment section. So it has 0 node. Okay, I got 0 radial node. So radial node is 0, right? So radial node is 0, and I have L is equal to 0 and M is equal to 0. So, but I know the formula of radial nodes, that is n minus L minus 1 is equal to number of radial nodes. Number of radial nodes. This is the formula, right? So you know that now. What is n value? We don't know, that we need to calculate. Minus L, it is 0, minus 1 is equal to number of radial nodes. Here we found out it to be 0, right? Because it came out to be boundary condition. Boundary condition are not considered to be node. Clear? So it would be n minus 1 is equal to 0, and it would be n is equal to 1. So I got here state n is equal to 1, right? So what we are doing now, we are trying to find states. Like, we will find n for this value, we will find n for this value, and we'll find n for our trial wave function, and then we'll see what trial wave function matches its n value with, and to whoever it will match the n value with, we'll just say that this energy obviously will be greater than that state which is having that energy. Okay, now this is getting complicated. I'll just tell you here only. Let's not get into this deep right now. So okay, what will happen now? Now I'll just, the main motto is just try to find out the value of n right now. Okay, so now I'm done for this ground state function. So now let's see for the next function, which is first excited state function. So first excited state function is this n1 2 minus sigma e raised to power minus sigma by 2, and it is denoted, energy is denoted by E1. Clear? So okay, now if I put it equal to 0, so n1 is equal to 0, that is boundary condition, and 2 minus sigma is equal to 0. So okay, now here I got one radial node. I got one. Don't get confused that sigma is equal to 2, then how come it is one radial node? Number is 1, like sigma is only 1, like sigma is 1. Suppose it was like this, n1 2 minus sigma and 3 minus sigma, then it would have been like this, that 2 minus sigma is equal to 0, sigma is equal to 2, and then 3 minus sigma is equal to 0, and then sigma is equal to 3. Now there are two radial nodes, like two radial nodes. One time sigma value is 2, one time sigma value is 3. So now here only one radial node is there, and the value is 2, like sigma value is 2. So now number of radial node is 1 here, because again this will be neglected because it is boundary condition, it is also boundary condition. I have only one node over here. So what I'll do, I'll just rub it first and then I'll make you understand. So I'll put it in the formula. So now I have got one radial node, right? So number of radial node over here is 1, Fine. So number of radial knot is 1. So I'll just find out n minus L is given, that is 0. Minus 1 is equal to number of radial knots, that is 1. So what it will become? N is equal to 2. So this state come out to be 2. Clear? So now let's come down to further thing. Let's just check what trial wave function belongs to which state. Clear? So trial wave function is again this thing, this belongs to boundary condition, this belongs to boundary condition. The only thing is 3 minus sigma is equal to 0. So sigma is equal to 3. So I got one node. So again I'll put it in this formula. So what I'll get? N minus L. What is L? Is 0. Minus 1 is equal to number of radial knot for this is 1 again. So n is equal to 2. So please tell me which state it belongs to. Obviously n is 2 over here, n is 2 for this one, and n is 1 for this one. So it corresponds, the trial wave function correspond to this because it matches with this state. So obviously we'll compare only these two things, not this or this. Fine, we'll not compare these things, we'll compare these two things, because the state should be same. Whatever trial wave function would be there, its energy, we'll compare it, the energy, trial wave function energy, with the same exact energy state. Clear? So don't get confused over here. So I'll compare its energy with this. So now I can conclude there was one condition when I was teaching the theory. So people who are new, you can go back and see that theory, that the main agenda is that whatever trial wave function energy will be, we don't know exact energy of trial wave function, but we can say that will be greater than or equal to exact energy. Fine. So I know that exact energy of third state. So now it was of second state. Like trial wave energy was of second state and exact energy is also of second state, then only we can compare. Clear? So E trial was given like E. Fine. So it was given as E. So it would be greater than equal to E exact, that is of second state, and E exact of second state was given as E1, not E naught. Fine guys, it is E1, second state, that means first excited state. So it will be greater than this E1, and you will find that E greater than E1, that would be the right option. And you can see over here, this option, like if I go to this A part, E is 0, that is incorrect. E is less than E naught, that is again incorrect. Fine. So because energy will increase over there and the ground state energy will be low, so here it is ground state energy is high, so it is again wrong. So trial wave energy again it's greater than E1. So now this thing I can digest, because the trial wave energy I found out that it is greater than E1. Then again E greater than E naught but less than E1, which is again wrong, because E should be greater than E1, which fits in C option. So hence C option is correct. And if you have any doubt, please leave it in the comment section. I'll be very happy to entertain your doubts, right? So I hope this question was a little bit different, like a lot of sigma things and all these things, find out n value, radial knots and all. So just if you have, please, it's my humble request, even if you have very small doubt, leave it, because I don't want you guys to have doubts in your mind. So I guess that's it with this one. I'll see all of you in the next one with a new question, and that question has appeared, that similar type of question appeared in December 2019 exam. So I'll see all of you in the next one. Till then, bye and take care, keep smiling, bye.